Okay, these notes and video is to help us with the chemical reactions that we are going to do in the practical tests moving forward. Okay, so generally in a chemical reaction, when we write equations, what do? We always take the positive, replace with the positive. And most of the time, these reactions will involve an acid. So I'm taking this metal, replacing it with the H plus of your acid. So the positive ones must always partner the negative. Okay, so never have like two cation ions like my Ca2 plus partnering your Mg2 plus. Two positive will not hold hand, will not partner together. Okay, and please know the positive is the surname, it will come first. Meaning to say if you have a formula like NaCl, this is the salt in the kitchen, right? Your positive Na plus comes first, followed by your Cl minus. It's called sodium chloride. We don't call it chloride sodium. Okay, with that in mind, please, these are the formulas that you have to memorize. Okay, with the theory as well. Your carbonate, ammonium, every time in a chemical reaction, when you see carbonate, think of carbon dioxide form. When you see ammonium, think of your ammonia pungent gas form. And the corresponding polyatomic ions formula, the sulfate, nitrate, to give you the corresponding acid, H2SO4 and HNO3. Okay, looking at the different possible chemical reactions that we will do in the lab. The first one is thermal decomposition. Okay, one reagent will break down into two or more products using heat. So decomposition is breaking down. Okay, most of the time, the reagent they will give you is a metal carbonate, right? So your carbonate again is your CO3 2 minus. The 2 minus must partner the positive metal. Okay, and carbonates are generally powder, and when you subject it to strong heat, it will decompose to the metal oxide and carbon dioxide gas. So in the lab, if you are given some powder, and they ask you to test for a gas when I heat it strongly, the gas you should go and test for is your carbon dioxide. Okay, don't go and test for hydrogen, oxygen, or ammonia. Those are not relevant. Okay, so you have example, your copper carbonate, CuCO3, right? Because the CO3 will always give me CO2. So what is left behind is your CuO, the copper oxide. Okay, so in a picture wise, this is what happened. You have some solid over here. Just heat it strongly under the flame, there will be carbon dioxide gas form. Okay, so in the practical, what do we emphasize on? We always emphasize on the observation. Okay, so what are the observations you will see? This gas, right? Every time when there's a gas form, the observation is here. Every time when there's a gas form, what do we write? Effervescence of colorless, odorless gas. Okay, so you will see gas being formed, and this gas, what color, what smell we have to write. Okay, so we identified that the gas is being formed, what color, what smell, and then we think about the test that we have to do to conclude what gas is it. Okay, so what's the test that we do? We bubble the gas through lime water. Lime water, you have to know, is your calcium hydroxide. Okay, and your positive result will be CO2 gives a white precipitate with lime water. Okay, so this is what is happening after you see that a gas is being formed. Connect it to a delivery tube again, which is connected to your lime water. So this one will be your lime water. Okay, and you bubble the gas through lime water, you will see a precipitate. Right, so the reaction, the positive test is over here in a chemical test that you're supposed to do. Okay, and what is really happening? You have CO2 gas, you bubble it into lime water. Okay, same thing, same idea. When you see CO2, always think of the carbonate that is being formed, the CO3 2 minus. So CO3 2 minus, what must it partner? It must partner the positive. Positive from your calcium hydroxide is your Ca2 plus. Right, so that's why you get your CaCO3. And then what's left behind? HNO. HNO will form water. Okay, this calcium carbonate, again, carbonates are usually powder, they are solid. So that's why you see a white precipitate. The solid white precipitate you see is your calcium carbonate. Okay, another type of possible reaction we can do is your precipitation reaction in the lab. Okay, so forming insoluble solid precipitates. Every time when we say precipitates are formed, these are solid and they are insoluble. So you know your cloudy stuff is solid, insoluble. Okay, how do we form precipitates? Generally, we usually add the alkali. Example, your strong alkali sodium hydroxide or your aqueous ammonia. Okay, please bear in mind, these are alkali. What are alkali? Again, they have OH minus. So both of it will have OH minus in them, your strong alkali and your weak alkali. Okay, so recall alkalis, they are soluble base, they ionize in water to give OH minus. And then metal hydroxides, they are all bases. Okay, if you cannot remember what's a base, please review your concepts again. Okay, they are bases, they are insoluble in water. So with the OH minus that you have, the hydroxides that you have, again, it is negative. What should it partner? Partner the positive. Okay, so in an example, for example, if you have aluminium nitrate over here, okay, this aluminium nitrate, what is going to happen? You're going to do a double displacement, or you're just going to swap partner. Okay, so my aluminium partner the OH and my sodium partner the NO3. So your overall result, you will get your aluminium hydroxide, AlOH3, and because hydroxides are bases and they are insoluble, you will see a white precipitate. Okay, you will see a solid and it's a white precipitate. Okay, so these pictures over here, this is a white precipitate, also white precipitate, also white precipitate. Okay, so depending when you do, when you add the alkali to an unknown solution, as long as you see white precipitate, write it as white precipitate form. Okay, and then when you swap your partner, the remaining behind is your sodium nitrate, NaNO3, which is just the solution that's surrounding it. Okay, another example, you have copper nitrate plus sodium hydroxide. Again, I swap a partner, my Cu2 plus partner the OH minus, positive partner the negative. So you get your CuOH2. And this is still a solid. Why is it a solid? Metal hydroxides are insoluble, they are solid. Okay, so this is a solid, but the difference between your aluminium hydroxide and your copper hydroxide is that this is a blue precipitate. So what do we mean by blue? If you see a blue color here, blue color here, these are all blue precipitates. Okay, and then your balanced solution, same thing, you have your nitrate partnering the sodium, you get sodium nitrate, and that's your solution surrounding it. Okay, in another example, your iron 2, Fe2 plus, partner the OH minus, you get iron 2 hydroxide. Again, hydroxides are solid, it's a green precipitate. Green precipitate examples are over here. Okay, and in another, the last common parts that we can test, you have your Fe3 plus. So your iron 3 partner the OH minus, you get FeOH3. It is a solid, iron 3 hydroxide. It's a solid, and this solid is a red-brown precipitate. So what do we mean by red-brown precipitate? This color, these are all red-brown precipitates. Okay, so depending on if this kind of question come out, a precipitation question come out, then look at the color correspondingly and just write whatever color that you see. These are the common colors. Okay, if you see orange, cannot be orange, it's more than likely red-brown. Okay, if you see pink, same thing, there's no such thing as pink precipitate. Yeah, so please take note, these are the common colors. Okay, other chemical reaction, we have single displacement reaction. So single displacement reaction, these reactions occur by mixing reagents together. Okay, same idea, I always take the positive, keep the positive partner the minus. Okay, so if you have your metal, which is positive, this metal will go and kick your copper to give you iron sulfate, right? So my iron partner the sulfate, and your copper, it is being kicked out. So this copper is being kicked out one time. We call it single displacement. Okay, and in a reaction, this is what is happening. Same thing, if you write the equation, you have your CuSO4. Okay, my copper, if you write your equation, you have your CuSO4. But what you're supposed to do is to take the metal, which is your iron, go and kick, because iron is not partnering somebody, so it tries to kick this. So your iron will partner the sulfate, it will kick the copper out. When it kicks the copper out, your copper gets displaced out. Okay, so in a lab, this is what could possibly be happening, right? You have iron metal over here. It could even be an iron nail. Okay, and then it's deep inside this copper 2 sulfate solution. Okay, copper solutions are blue in color. Okay, so you put this iron inside, and after a while you will see, right, you take it out, you will see it looks like black solid is around it. Okay, this black solid is actually not really black, right? This is actually the copper that is being kicked out, and the copper that is being kicked out just coat around the iron layer. Okay, and you see your blue color, it becomes slightly lighter, and if you put it long enough, then the blue color would decolorize completely. So same thing in the laboratory, they always ask you, what's your observation? What's your observation? We are keen in the observation. Blue copper 2 sulfate decolorize, it becomes lighter, and you see a red-brown copper deposits on iron. So this black stuff that you see, because it's copper, it's not black, you have to write it as red-brown. Okay, next few, single displacement reaction. Another example, we have acid plus metal. So acid plus metal give you salt and hydrogen gas, right? Remember, you take your metal, kick the H+. So my metal kick the H+, my magnesium will partner the minus, which is your Cl minus, you get MgCl2. The H2 kick it out, you form hydrogen gas. This is one-time kicking, kick one thing out. So this is your single displacement. Okay, and in the lab, same thing, they are interested in observation. What's the confirmatory test, right? So this one, because your hydrogen gas is being formed. Okay, what's your observation? The gray solid dissolve, right? Because this is magnesium metal piece, it is a gray solid. It will dissolve, become smaller, because ultimately it forms salt. And then because of your hydrogen gas form, you see effervescence, the bubbling of colorless, odorless gas. Repeat, the observation is here when you do the experiment. You see the gray solid dissolve, you see bubbling. So effervescence, what color, what smell, all your words have to be there. If you miss out any point, I don't think you can get the full mark. Okay, and how do we go about testing? Because this gas that comes out is just bubbles. How do we test that this gas is really your hydrogen gas? So the lighted spleen will extinguish with a pop sound. So use your satay stick with a fire. If it is hydrogen, it will extinguish and you will hear a pop sound. Positive test for hydrogen gas. Hydrogen gas is only formed when you have a metal reaction. If the question gives you a powder plus an acid, please don't go and test hydrogen, because powder, no chance to form hydrogen gas. What will form hydrogen gas? Only your metal, which looks like gray solid. Okay, and also do take note, copper is unreactive. Okay, and copper, the color is red-brown. Okay, this is found inside your wires. The color is red-brown. It's not gray. Okay, because your copper is unreactive, it does not react with the acid. Okay, and the other example that we have in your chemical reactions is your double displacement. Most common example is your neutralization reaction, which is your acid plus alkali. So same thing, take the metal, kick the H+, your metal partner the Cl, you get your salt sodium chloride. Okay, and then the H will partner the OH to form water. Okay, hydrochloric acid is colorless solution. Sodium hydroxide is colorless solution. Salt dissolved in water, colorless solution. So this one, what's the observation? No observable change. Okay, no observable change. Don't say no reaction taking place. Okay, because the question say what we observe, what we see. So write what you see. You see nothing, don't just say nothing. Say no observable change. Okay, but all neutralization reaction, the reaction will feel warm. So even though it's all colorless solution mixed together, you touch the test tube, it will feel warm. And normally, how do we know neutralization reaction take place? I add universal indicator, and the universal indicator will turn green because pH 7. Your salt is neutral, your water is neutral. Okay, the next example, double displacement reactions of acid with carbonate. So carbonates, please remember these carbonates are powder. Okay, so again, the CO3 2- partner, the positive is always a metal carbonate, right? And whenever time you see a carbonate, think of carbon dioxide. So my calcium partner, the Cl-, you get your calcium chloride, and your CO3 always think CO2. So same thing, positive test for the result that is happening, right? Carbon dioxide gas, this is your observation, right? What do you see? Bubbling, and you see the powder dissolve. So you say your solid dissolve, and you see bubbling. So effervescence, colorless, odorless gas. Okay, and your positive result over here, for it to be CO2, you will have a white precipitate with lime water. Okay, remember your lime water is calcium hydroxide, right? And the solid, the white precipitate that you see because you swap the partner is calcium carbonate. Okay, and the last reaction we have for double displacement reaction is your alkali plus ammonium salt. This will give you ammonia gas and water. Okay, so this reaction, I take the metal, kick the NH4, partner the Cl, right? My metal always partner the negative. My NH4 will always give me NH3, ammonia gas, your pungent gas. Okay, and then what else is left behind? You have H and O form H2O. Okay, so same thing, this ammonium salt is usually powder as well. It's a powder. Okay, when you add the alkali inside, be sure your alkali don't touch the test tube. Okay, sometimes your alkali go and touch the test tube, you put the litmus paper, and your litmus paper touch the test tube mouth, then that's worse, right? There's already alkali there, of course your litmus paper will turn color. Okay, what you're trying to do is to test for the gas that comes out, and this one is your weak alkali. We have to know this. Ammonia is your weak alkali. Right, so with this weak alkali, do not go and touch the mouth of the test tube. Make sure it's just hanging out, never touch anything, and it's only touching the gas. Okay, so observation, what will you see? Same thing, observation is always here. There's no observable change. Okay, the solid may dissolve. Okay, if you see the ammonium salt, if it's solid, it will dissolve. But because it's ammonia gas, you will not see effervescence. You will not see bubbling, right? Because alkali is very soluble. So you will not see bubbling. Okay, so there's no visible change you can really see. But if you touch the test tube again, it will feel cold. Ammonium reactions, it will always feel cold. Okay? And then even though you have no observable change, what you can do is you can smell it. So the result is your colorless pungent gas. Okay, no color, but the smell is pungent, is no longer colorless. Okay, and this colorless pungent gas will turn the moist red litmus paper blue because your ammonia gas is a weak alkali. Okay, so in practical, be very clear. You know how to write the observation, the results, as well as the test for all the things that we discussed in this video.